All right, so we think of the distributive property as a way to multiply a monomial and a polynomial. So if we have 2 parentheses x plus y, then we distribute and we multiply and get 2 times x plus 2 times y. But this distributive property can also be undone, and we call this undoing factoring. So we're going to factor, which is like dividing. So normally we multiply, and factoring is going to be dividing. So what we're going to have to do is we're going to have to use that concept of a GCF, and we're going to look at both of these and think what number is in common to both of them. And you can see there's a 2 in both of them. That's pretty obvious. And so what we're going to do then is we're going to pull the 2 out front. Way. So here it was this way. We're going to go backwards, pull the 2 out front, and think 2 times what is equal to 2x? Well, 2 times x. And plus 2 times what is equal to 2y? Well, 2 times y. And this would be called the factored. This is factored form right there. All right, so let's do a few of these. So right here, we're going to factor the GCF of these 2 terms from each expression using the distributive property backwards. So I'm going to look at 3m to the third and 6m to the second, and I'm going to think, what do they have in common? What's the biggest number that divides into both 3 and 6? We'll always start off with this one. 3 goes into both of them. So 3 is going to come out. That's going to be part of the GCF. And then how many m's do they have in common? Well, they both have 2 m's in common. So I'm going to put this down. So I'm going to put the GCF of that in front, and then I'm going to think, what 3m squared times what will give me 3m to the third? Well, what am I missing? I'm missing an m. And then 3 times what is going to give me a 6. What am I missing? Well, I need 3 times. I need a 2. And then I don't need any more m's. So that would be my factored form. For B, what do they have in common? 4 goes into 4, but 4 does not go into 10. So the next number that goes into 4 is a 2, which will also go into 10. So 2 is going to be part of my GCF. And then I'm going to look at my A's. How many do they both have in common? Well, they both have just the one A. So I'm going to write that, put my open parentheses, and ask myself, 2a times what? It's going to give me 4a squared. Well, what am I missing? I'm missing a 2. 2 times 2 is 4. And I need one more a to give me a squared. Minus 2 times what is 10? Well, what I'm missing is a 5, and I don't need any more a's. So if the leading or the highest degree term of a polynomial is negative, you're going to factor out the negative of the GCF. And if the polynomial is not in standard form, write it in standard form first. So let's just take a quick look. You see this is in standard form. It's got the biggest exponent first, and there's the smallest one. The leading exponent is and the leading coefficient is negative. So when I factor out a GCF, I'm going to take out a negative. All right, so now GCF, the biggest number that goes into 3 is 3, and it also goes into 12. So I'll put a 3 there. How many m's do they have in common? M to the third, and that's going to take, when I divide a negative and a negative, so what? Negative 3 times what is negative 3? Well, 1. I'm not going to write a 1 unless I have to. And then m to the third times what gives me m to the fifth? M to the second. I always double check it. You can see that that multiplies back. Then negative 3 times what is going to give me a negative 12. Oh, negative 3 times it's going to have to be positive to give me a negative 12, and this is going to be a 4. So negative 3 times positive 4 is negative 12, and I don't need any more m's. For B, it's kind of odd, but you see again it's a cubed a, so it's in order. My leading coefficient is negative, so I will take out a negative, and 2 does go into both of those. So I'm going to take out a 2. For my A's, it looks like they only have 1 in common, and they also both have 1 B in common. So negative 2 times what's negative 2? Well, 1. A times what is a to the third? That's missing a to the second. I don't need any more B's. So the sign negative times what is going to give me a positive 6? Well, that's going to be a negative 3. Negative 2 times negative 3 gives me positive 6. I don't need any more A's and I don't need any more B's, so I am done with that. Example 5, we're going to have to write it in standard form. So on this one, you see that it has the x cubed before the x squared. So this is a negative 21, and when I rearrange these terms, the negative is going to go with it. So this negative 1, 21, x to the third plus 7, x to the second. In common is going to be a negative 7, x squared. That is going to leave me with a 3. Notice that gives me negative 21. 3x. Negative times a negative is going to give me a positive. And, I don't really need anything here. I've got to hold, so this is kind of an important one. I've got to hold this place. I can't just leave it blank because remember, I've got to distribute to get these. So negative 7x squared times negative what gives me that? Negative 1. So there needs to be a 1 in that spot. Again, here's another one. This time I'll have 20x to the third minus 4x to the second. I'm going to take out what's going to go into both of those is a 4x squared. And that's going to leave me with 5x minus, and again, I don't need to multiply by any numbers or variables. So I'm going to put 1. 4x squared times 1 is 4x squared.